Math 111 students, we are in 6.1 today, and we're just going to jump right in and get started. Now we are doing the official, hang on, we are doing the official inverses today. Remember, I have had a long problem of calling cosecant and secant and cotangent the inverses of sine, cosine, and tangent. They're not, though. They're the reciprocals. Okay, you just flip them upside down. The technical inverses of sine, cosine, and tangent are what we're going to talk about today. And let's just review real quick Math 110 concept of one-to-one functions. In order to take the inverse of a function, your function has to be one-to-one. And that means, remember, all functions have to pass the vertical line test, right? But a one-to-one function has to also pass a horizontal line test. All right, well, while the sine function passes the vertical line test, it does not here pass the horizontal line test. So we can't technically take its inverse unless we restrict the domain, and that's what we're going to do. We are going to restrict our domain of our sine function just to this part in blue so that we can actually take its inverse. So we're going to restrict our sine function from negative pi over 2 to pi over 2. So that's going to be the domain of the original function. The range of the original function will be from -1 to +1. So here's our range of our original function. And if you remember the definition of inverse functions, for the inverse function, the domain of the original becomes the range of the inverse. And the range of the original becomes the domain of the inverse. Okay, so let's think about that in terms of this portion of sine. All right, inverse function, I've got them both drawn here. An inverse function flips the x and the y value. It's going to be when you graph it, it's going to be a reflection across y equal to x. So the red is our original sine function. Our original sine function when pi over 2 was 1, right here. All right, well, on the inverse, it will be 1 pi over 2. And see how that's just a reflection across the line y equal to x. On our original, we had negative pi over 2, -1. On the inverse, that becomes -1, negative pi over 2. Remember, on our original, our domain was negative pi over 2 to positive pi over 2. Okay, well, look, that is now our range on our inverse. So our range, our inverse goes down to negative pi over 2 and up to pi over 2. And then on our original, our range, it went down to -1 and up to +1. Well, now that's our domain on our inverse. Our blue one starts at -1 and goes to -1. All right. Now, the inverse, remember that the original sine function, okay, on our original sine function, y equals the sine of x, you're going to plug in an angle like the sine of pi over 4, and you're going to get, so you plug in the angle and you get out the sine at the angle. So in this case, it would be √2 over 2. You plug in the angle, you're going to get out the sine. With the inverse, we're going to give you the sine, and your answer is going to be the angle. Okay? So think, I am giving you the sine of -1, and I want you to tell me, well, what angle is that? We're going to get out the angle. All right. Now we're thinking, remember, we're restricted from negative pi over 2 to positive pi over 2. So I'm going to pull up my cheat sheet here. On the sine, we're restricted from negative pi over 2. So that's the same location as 3 pi over 2. Start here at 0. And if you go in the negative direction, you end up at negative pi over 2. So from there all the way around to positive pi over 2. Okay. And we want to know in this area, in this range, when is the sign -1? And my cheat sheet's real helpful. When is the sign -1? Ah, here at 3 pi over 2. 3 pi over 2. Where's 3 pi over 2? Well, 0, 1 pi over 2, 2 pi over 2, 3 pi over 2. Well, remember though, 3 pi over 2 technically is not in the range here. It's not in the domain of the original. However, negative pi over 2 is, and it's the same location. So my answer here would be negative pi over 2. At negative pi over 2, the sign is -1, and that is within the scope of where I can do this. Right. So we get here negative pi over 2. And they go through a long explanation, but it was right there. Negative pi over 2. All righty, let's try another one. Inverse sine, at what angle do we get a sine of √3 over 2? Okay, so let's say you could write it in a different way. You could say sine of what angle equals 3 pi √3 over 2? The sine of what angle, and this angle has to be in between. We've restricted the angles it can be from negative pi over 2 to positive pi over 2. Okay, so what in that area will give you a sine of √3 over 2? So let's look again at our handy dandy cheat sheet. I'm going to look again down my sine column, and I'm looking for √3 over 2. Sine column, √3 over 2. Right there, pi over 3. 2 pi over 3. And that's the only one. So pi over 3 and 2 pi over 3. Pi over 3, well, that's in the part that I needed to be, but 2 pi over 3 is not. So my answer is right there, pi over 3. Switch back to my other screen, and sure enough, after much explanation, you see there pi over 3. All right, how about if we want to do it on the calculator? All right, sine inverse 1/3, and we want to express our answer in radians rounded to 2 decimal places. Inverse sine of 1/3. All right, so let's go back over here and I'll show you on my calculator. The inverse sine of 1/3, where they said in radians, express the answer in radians. So I'm going to go to mode here and make sure I'm in radians. And then you can quit out of that. And I am going to use the inverse sine button that's here above sine. So I'm going to go second inverse sine, and we had 1 divided by 3. All right, and I get 0.34 radians. Let's think about what 0.34 radians means. All right, 0.34 radians. Remember that one all the way around here is pi radians, and pi is 3.14 radians. So then pi over 2 would be about half of that. Pi over 3, let's see, what's pi divided by 3? That's about 1 radian. Okay, so pi over 3 is about the closest to 1 radian. And so then we've got how many radians? We have about 1/3 of that. We have about 0.34, roughly 1/3 of that. So let's divide that by 3 again. How close would that get us? That would get us really close. So what is pi over 3 divided by 3? What is 1/3 divided by 3? And let's switch that back to a fraction. It's 1/9. Okay. So think of pi over 9, which is somewhere around here. That's the one. pi over 9-ish, real close, would have the sign of 1/3. Okay. And your book does show you this one, 0.34. All right. How about the second one, which was the inverse sine of -1/4? Same way. Inverse sine, -1/4. Now we get -0.2526. That's roughly a fourth of a radian. And so if pi over 3 is roughly approximately 1 radian, then a quarter of that, a -1/4 of that. So let's take pi over 3, roughly 1 radian, and divide it by 4, or which would be pi over 3 times 1/4. So that's pi over 12, but we are going in the negative direction. So around negative pi over 12, that would be a close approximation. All right. All right, use the properties of inverse functions to find exact values. Remember that the inverse undoes the original, but you got to be in the right domain and range, okay? The inverse undoes the original. So if we are in the right domain and range, the inverse sine of sine is just pi over 9. So let's just look here and let's make sure that pi over 9 is in our right area. Let's see, I didn't share the right thing. Or maybe I did. Can you see that? All right. So pi over 9, if this is pi over 6, pi over 9 is over here, and that is in the right area. We have to be between negative pi over 2 and positive pi over 2, and pi over 9 is right here. So we can just simply take the inverse sine of the sine of pi over 9, and it will be pi over 9. All right, hang on, folks. I've lost. All right. Next one, inverse sine, the sine of the inverse sine of -2.5. So we could say, well, that's just -2.5. They just undo each other. The only problem is, does that fit into our range? All right, and here's the problem. What is the range for sine? It's -1 to +1. So can you plug in -2.5 into the inverse? No, that's out of the range of what sine would ever be. Sine's never going to be lower than -1. Okay, so it's not defined here. All right, same thought with cosine, except now instead of from negative pi over 2 to pi over 2, we're going to restrict it from 0 to pi. It's going to be restricted from 0 to pi. And so the domain of the original is from 0 to pi. So that'll become our range of our inverse. But still, again, the range of the original is from -1 to 1. And so the domain of the inverse will be -1 to 1. All right. And if you flip this one across the line, y equal to x, all right, so the red is our original, so you had the 0.01. So now on the inverse, you have the 0.10. The red was the original. We had the pi over 2, 0. So now we have the 0.0 pi over 2. On the original, we had the pi -1. And now we have the inverse, -1 pi. Reflection across the line, y equal to x. All right, so how about the inverse cosine of 1/2? At what angle between 0 and pi does the sine equal 1/2? All right, well, let's go up here. We'll go back to our little cheat sheet. So we're wondering, when does the cosine's the second column, when does the cosine equal 1/2? Here it is right there. And pi over 3 is between 0 and pi, so this is right where I need it. So our answer is pi over 3. Lots of explanation, but here you go. How about the inverse cosine of negative root 3 over 2? Negative root 3 over 2. Again, I'm going to go over to my little cheat sheet here. Negative root 3 over 2 cosine, here it is, that 5 pi over 6, which is in between 0 and pi. So I can do that, 5 pi over 6. Lots of clicks to tell us that, 5 pi over 6. All right, Tay. Again, they undo each other. So inverse cosine of cosine pi over 15. Well, pi over 15 is in between 0 and pi. Okay, so we can take that. It's just going to be pi over 15. All right. Negative 3 pi over 4 is not between 0 and pi. But let's see where it is. Okay, negative 3 pi over 4 is going to be here. Negative 1 pi over 2. Excuse me, negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. It's over here. It is not between 0 and pi. So at first we might think, can't do it. There is one more thing, though, to consider with cosine. Do you remember that cosine is even? Cosine is even. And that means that the cosine of negative 3 pi over 4 is going to be the same as the cosine of positive 3 pi over 4. And you could do that, right? Inverse cosine of the cosine of 3 pi over 4. Yeah, that's just going to be 3 pi over 4. So since it is even, we actually could take it, even though the original problem was not in the appropriate domain. There's a long explanation for that. There you go. All right, Tay, last but not least is tangent. Tangent has an asymptote every odd pi over 2. And we are going to restrict ours just again. This one's going to have the same restriction that sine did. Sine was restricted from negative pi over 2 to positive pi over 2. And we're going to restrict tangent that way too. So the domain of our original will be from negative pi over 2 to pi over 2. And that'll become our range of our inverse tangent. The range of the original goes from negative infinity to positive infinity. That will become the domain for our inverse. All right, and you can see that clearly here on the sketch. So the red again is the original. Notice how that's a reflection across the line y equal to x. And notice now how the image helps you see that your domain on the inverse is all real numbers, but your range is restricted between negative pi over 2 and positive pi over 2. All right, Tay, let's try the inverse tangent of negative root 3 over 3. All right, let's look it up on our cheat sheet. Negative root 3 over 3. I'm looking in my tangent column now. Negative root 3 over 3. That's at 5 pi over 6. That's not where I want to be, I don't think. But let's look. 5 pi over 6. 1, 2, 3. 5 pi over 6 is over here. That doesn't help me. I need to be in this area. All right, so let's see if there's any more. Negative root 3 over 3 on my tangent. Keep on, keep on, keep on. Aha, 11 pi over 6. Is that where I want to be? Yeah, look, 11 pi over 6 right here. Except I'm not going to call it 11 pi over 6. I got to think of it in the negative direction. 11 pi over 6, if I'm going in the negative direction, is the same thing as negative pi over 6. So the inverse tangent here will be negative pi over 6. Again, if I'm going too fast, put me on 0.75 speed and slow me down. By the way, let's see, does it show us negative pi over 6? Here we go. Real quick, keyword for today, the magic word is the northern right whale. Northern right whale, not the wrong whale, the right whale. Anyway, northern right whale is a good one to have on your radar because they are on the endangered species list. In fact, although there are other right whales elsewhere in the world, the northern right whale, which is in the Atlantic Ocean, I'm pretty sure only has about 360 left in the population. So it's like really critically endangered. Northern right whale, email me your keyword at alsupwh@octech.edu. All right, Tay. Continuing on. Just like the others, you can inverse. The inverses undo each other. That's the bottom line. Oh, okay. Well, this one's a little bit more complicated. So we're going to find the inverse here of 2 sine x minus 1. Same domain originally. So that'll become our range of our original one, or our new one. Now remember that sine the inverse means to switch your x and y. So our original function, this is our original guy, y equals 2 sine x minus 1. And for the inverse, we're going to flip our x's and our y's. So now we have x equals 2 sine y minus 1, and we need to solve for the y. That's the old method we learned back in Math 110 for figuring out an inverse. So I'm going to solve for the y. Got to add 1 to both sides. X plus 1 equals 2 sine y. Divide both sides by 2. 2's cancel out. Oops, excuse me. And you got the sine of y equals x plus 1 over 2. And then you can take the inverse sine of both sides. So the inverse sine of both sides, I'm running out of room to write it, but it'll be the inverse sine of x plus 1 over 2, and the inverse sine of sine cancels out. So I've got y equals inverse sine x plus 1 over 2. All right, so that's the inverse function then. And now we have to think about domain and range. Okay. Think about the domain, or let's see. Yeah. Think about the range of the original one. Okay. So I'm going back to my original function, which was not the range of y equals sine x was the range of that one was -1 to +1. Okay, but that's not what we've got. We've picked ours up and we've transformed it a little bit. We picked it up, moved it down 1 on the y. We've got the amplitude, you know, is rising it up to 2 and down to -2. So if you were just thinking about that, that's your amplitude. Okay, so if you were originally going from -1 to +1 with an amplitude of 2, you've stretched out from -2 to +2. Okay. But then we pick it up and move it down 1 on the y. So instead of being at -2 on the y, you picked it up and moved it down 1. It was at -3 on the y. Instead of going up to 2 on the y, you pick it up and move it down 1. You're at +1 on the y. So, and we're talking about range of the original. So the range of my original after all the transformations was -3 to 1. That becomes the domain of our inverse. Okay, that's going to become the domain of our inverse. All right, so the domain of the inverse will be -3 to 1. All right, now the range of the inverse was going to be the domain of the original, and that was a little bit easier. That was from -pi/2 to +pi/2, and that's now the range of the inverse because that was the domain of our original. It was only the range of the original. That was a little bit harder to find. All right, go back up through that on 0.75 speed if I lost you there. Solve equations involving inverse trigonometric functions. All right, we've got 12 inverse sine x equals 3 pi. Well, what angle are we looking for? All right, let's just solve it. We're looking for the divide both sides by 12. So we are looking for the inverse sine of x of pi over 4. All right, so undo it by taking the sine of both sides. Okay. Sine undoes inverse sine. X is going to equal the sine of pi over 4. And that is in our right domain. It'll be root 2 over 2. Root 2 over 2. All right, Tay. Well, we did a lot there. Keyword, northern right whale. And I hope that you understood that. If not, you can email me at alsipwh@octech.edu. You can use the Ask My Instructor button in Pearson. I'll get back to you pretty doggone quick. I'm pretty good about that. Or call me at 268-2516. All right, have a good one. Bye.